Hey everyone, and welcome to this explainer. Today we're going to completely transform how you look at massive databases. You know that feeling when you're just staring at an endless spreadsheet or a giant database table and wondering what it actually all means? Well, if you've been there, you are absolutely in the right place. Today, we're not just learning to write SQL queries that fetch data, we are writing queries that actually drive real-world decisions.
All right, here's our game plan for today. First, we'll talk about taming the data mountain, then jump into the core aggregate functions themselves. After that, we'll look at grouping data, filtering those summaries, making real-world decisions, and wrap up with how to avoid some of the most common SQL mistakes. Let's get to it.
Starting with Section 1, Taming the Data Mountain. Let's set the stage for why we even need these tools in the first place.
I mean, seriously? Imagine having to manually scroll through 10,000 hospital records just to figure out if you need to hire more nurses for the night shift. Or trying to find the highest test score in an entire school district by clicking through every single student's file one by one. Staring at a mountain of raw data is completely useless for big picture analysis. Without a way to summarize things, you're stuck inspecting every single row manually. It's incredibly inefficient, it's super prone to error, and frankly, at scale, it's literally impossible.
Well, this is exactly where aggregate functions swoop in to save the day. They do all the heavy lifting for us. By definition, aggregate functions are database tools that combine many values into one single powerful result. Basically, they act as the bridge that gets you from raw, messy rows of data to crystal clear summaries. So whether you need to figure out your total sales for the month or spot the absolute highest score in a class instantly, aggregates are the engine that makes your database actually useful.
Moving right along to Section 2, Core SQL Aggregate Functions.
You've essentially got 5 main tools, or weapons really, to tame this data mountain. First up is count. This one literally just counts the rows, which is perfect for asking things like, how many students are enrolled? Next is sum, and that adds numeric values together. Think, what's our total income this month? Then we have AVG for finding the average test score, max for grabbing the highest salary, and min to spot the lowest stock level so you know exactly when it's time to reorder. One quick note here, count usually uses an asterisk to count total rows, while the other 4 are applied directly to specific numeric fields.
And you know, the result of a well-written aggregate query is just so satisfying. Think about tracking thousands of individual food sales. A sandwich here, a coffee there, day in and day out. With one simple function, all that noise completely collapses into one clean total, 1,200. That single number tells a manager everything they need to know, without ever having to look at a single receipt.
Now, getting this to actually work, the syntax is surprisingly straightforward. You literally just use your select statement, call the function, like sum or AVG, and drop the column name in parentheses right after it. Then just specify the table with your from clause. But it is super important to remember that writing a query exactly this way summarizes the entire table. It gives you one massive grand total or average simply because no grouping has happened yet.
Which brings us perfectly to Section 3. Grouping data for insights.
Because, let's be real, sometimes one massive grand total just doesn't cut it. We need to categorize our summaries, and that's exactly the difference between simple aggregates and group data. A simple aggregate summarizes everything into one result, but adding a group by clause, that creates a summary row for every single category. Think of group by kind of like sorting laundry. Instead of tossing everything into one giant pile to weigh it, you're organizing the data into neat labeled baskets, like subject, department, or product type, and then weighing each basket individually.
When you drop that group by clause onto a category field to sum up sales, boom, the trends are immediately obvious. Instantly, we can see books at 850, food at 1,200, and uniforms at 500. You don't have to guess which department is bringing in the most money. Comparing these 3 little summary rows is just infinitely easier than trying to decipher thousands of raw transaction records.
Okay, pause for a second, because we need to talk about the golden rule of SQL. Honestly, this insider tip is going to save you hours of debugging headache. If you are selecting a normal field, like category, alongside an aggregate calculation like the sum of amount, that normal field absolutely must appear in your group by clause. If you select category but forget to group by it, the database engine basically just gets confused. It has no idea how to display multiple categories against a single summarized total. So always remember to match your selected fields with your grouped fields. All right, moving to Section 4, filtering and sorting summaries.
So we've got our groups, right? But what if we only want to see the departments that have an average salary over 3,000? To pull that off, you really need to understand the order of operations in SQL. Step 1 is where. Where filters your raw rows before any grouping even happens. Step 2 is group by, which actually forms your groups. Step 3 is having, and this is crucial. Having filters the grouped results after they've been summarized. Finally, step 4 is order by, which sorts your final output. Think of this sequence as your mental cheat sheet. It draws a very hard line between filtering raw individual rows with where and filtering your newly grouped summaries with having.
Next up, Section 5, Real-World Data Decisions. This is where the magic actually happens.
Because a good SQL query doesn't just put numbers on a screen, it drives real actions. Take a hospital, for example. If you run a count of patients and group them by ward, like surgical, ER, pediatrics, ICU, management isn't just looking at random statistics. They are looking at exactly where they need to increase staff for the night shift. That one query directly guides human resource allocation. Or, think about a school database. By finding the average mark for each subject using the AVG function and grouping by subject, a principal can immediately spot exactly which departments are struggling. Maybe math needs more tutors, while history's cruising along just fine. The aggregate function makes that insight possible. You could even use min on your inventory database to check stock levels, spot shortages, and reorder products before you actually run out.
And finally, Section 6, avoiding common SQL mistakes.
Before you go off and build your own executive reports, let's just quickly go over where people usually mess this up. First off, trying to use sum or AVG on text data. That's like asking for the average of the words Bob and math. It just doesn't make any sense. Always make sure your field types match. Aggregates generally need numeric data. Second, and we touched on this, forgetting the group by clause when you select a normal field alongside an aggregate. Third, using where instead of having. Just repeat after me, where filters raw rows, having filters groups. And lastly, if you're taking an exam or presenting to a boss, don't just dump the syntax on them. Always explain what the result actually means in the real world.
So as we wrap up this explainer, I want you to keep this one thought in mind. At its core, data is literally just numbers. It's raw, unstructured potential. But when you apply aggregate functions, you bring order to all that chaos. Taming the data mountain is really just step 1. The true value is in the actions you take from those insights. So the next time you sit down to write an SQL query, ask yourself, what decisions will your queries drive? Thanks so much for joining me on this explainer, and hey, happy querying!